Okay, we're on the MyLabsPlus page. We talked about syllabus and pacing, study plan, quizzes and tests. Again, we have QuizMes, but you don't get them this way. I showed you how to get those already. Textbook is there in chapter contents. Video notebook would be pages that if you watch the videos related to the textbook, you could take notes on that. Tools for success are also there. Multimedia library, this is where the videos are. There's also PowerPoint slides and other things. But I'd like to look at Student Organizer. So when I clicked on Student Organizer, this is what we got. And it's going to have these types of things. Remember, you can always pause the tape or go back if you want to look at something in more detail. So let's click on Student Organizer. And basically it looks like this. And there's the table of contents, Chapter 1. And again, we're doing Chapter 1, 2, 3, 4, and 5. Just wanted to show you how this works a little bit. So we're going to click on Chapter 1. And I'm going to make it big so we can see it better. There we go. So section 1 of chapter 1 is just helpful hints to do well in a course. And I have a video on that, and we'll skip that for now. But this is what these helps are like. And you could print any of this out that you like. Now it's telling you to read the objectives on page 7. Again, you would use this with your textbook. Read the helpful hints. There's some helpful hints that give you areas where students sometimes get those either concepts or things incorrect, and they just remind you of what to look for. And then they're going to ask you to complete some of these. Now again, we have our workbook. We'll be doing some there. And this is only if you'd like to do a little more. So, what are they looking for here? Well, these symbols, not equal to, less than, and greater than, are called, and if you only want to take a little bit of notes, you could put this in another notebook and just pick out the things from this that you think you'd like to remember. These are called inequality symbols. Inequality. All right, it says look at the common sets of numbers diagrammed on page 11. And then from the diagram, all integers are also elements of what two sets? Now on this page, they're giving you, and I'm writing some of this out here so you could see it, the natural numbers, 1, 2, 3, ellipsis, whole numbers, we just add a 0 to it, and then your ellipsis. Now integers are whole numbers and their negative opposites. So it starts, as you recall, as coming from negative infinity with the pattern negative 2, negative 1, 0, 1, 2, and then the ellipsis again there. I didn't get that in there too well. So there it is correct. Now, rational numbers were all of these, but also the fractions that were in there, like 1/2 and 1/3. And 1/2 when it's converted to a decimal, is 0.5. And when 3 is, and it terminates there, when 1/3 is converted to a decimal, it becomes 0.3, and the 3's repeat. So we put a little repeating bar over 3 to indicate that. So if a fraction, when it's converted to its decimal form, terminates like this, or has a repeating pattern like this, we say it's a rational number. And then there are other numbers on the number line that are irrational, such as the square root of 2, the square root of 3, the square root of 5. Now you might say, what happened to the square root of 4? Well, the square root of 4 is actually 2. So even though it has the radical sign on it, it is a perfect square. But those that are not perfect squares under the radical sign are considered irrational numbers. Some other irrational numbers are pi. And later, you're not going to have it now, but I'll just tell you, is the letter E. We don't have it in this course. So pi and radicals whose radicand, that is what is under the sign, are not perfect squares. But all of these numbers are real numbers. So the background in answering number 2 here, where they want you to think about it, where they have these sets in your diagram on page 11, they're saying integers belong to what other 2 sets? Well, they don't belong to natural numbers. They don't belong to whole numbers. But they do belong to rational numbers and real numbers. All numbers are real numbers. Integers are rational and real. So they're asking you to just think about that, and then this would be the background that you get from reading the textbook or listening to our lesson in class. I think we're going to do this on our very first day. Okay, so as you read your textbook, and my daughter is a good example of this, that when she took her first class, she didn't do very well that first semester. In fact, her midterm grades were 3 F's and 2 D's. So she realized she had to change something. And what she did is, instead of just reading the textbook once, she would read it twice and sometimes 3 times, and then take notes. What we've done and what this author in our textbook has done is given you all these tutorial items to help you just repeat and repeat and try to get these skills mastered. So this is where you would maybe take some notes on what we're doing, or from the videos, or reading the textbook, and there you're going to have some examples. And here they're giving us the answers. Oh, okay, so inequality symbols, and this was rational numbers and real numbers. We had said that, but I think I missed this number 3 there. Okay, oh, I see, I did. Looking at this, this is the absolute sign for letter A. The absolute value of A is the distance between A and 0 on the number line. And an absolute value of something is never negative. Okay, I think we're going to cover all of this in our class, but this is just to show you another set of materials that you might do if you need that little extra work. And again, we're going to be doing something very similar to this in our workbook, but let's just go over this. Now what they're asking us to do here is to insert these symbols to make these statements true. So 2 is less than 3, 7 is greater, 72 is greater than 27. And here they're reviewing this with you. And then now they're asking you to do something. 7 is greater than, 0 is less than. So it may be almost overkill whether you would use something like this, but then again, everyone's skill, some go faster, some go less fast. You want to get mastery so that when you take your test, you know. And as the hippie answered the fellow who asked him, how do you get to Carnegie Hall? He said, you got to practice, man. You got to practice. And that's what we're doing. We're practicing. So here is some examples. Translate each sentence into a mathematical statement. 9 is less than or equal to 11. This would be English. This is mathematical. 8 is greater than 1. 3 is not equal to 4. Okay, 5 now. Let's start this one. 5 is greater than or equal to. So there's the greater than. There's the equal to 4. 15 is not equal to negative 2. 15 is not equal to negative 2. And I see now how this is laid out. On this side, they're actually giving you examples from the textbook, in a sense. Here is a given set of real numbers. List the numbers in the set that belongs to. This was our n, our natural numbers. This is 1, 2, 3. So that would be this one. They're not in order. And this one. And that's what they have. Whole numbers. Now we add a 0 to that. And these others. Let's see if I can make that. There we go. Integers also include negative numbers, but in a sense, negative whole numbers, the opposites of these. And then rational numbers, as long as they are either any of these are all rational numbers, plus the fractions that either terminate or have a repeating pattern. And then the irrational and real numbers are all of them. So tell which set or sets of numbers that this fraction belongs to. Well, it's not a natural number. It's not a whole number. It's not an integer. It does have a repeating pattern in its fraction form. And it is all numbers are real. So it's these two categories. Okay. Now in number 7, they're asking us to find the absolute value. Remember, absolute value is the distance that something is from 0. So whether it's on the left side and they're negative values that go up to 0, and we're just going to count them. So these are going to be positive units that it is from 0. And if it's on the positive side, we just go from 0 to that point. So whatever value is in the absolute value sign, the output, the outcome of it, is always positive. So 4 and 5. And there is, we want us to put these inequality symbols there. So the first thing we have to do is do this. Take the absolute value of -5, and that gives us a 5. So 5 is what compared? Well, 5 is greater. And 0, its absolute value is 0 because it's right there. And this becomes a positive 8. So 0 is less than a positive 8. And actually here they're summarizing again all of the answers. And they say here next, do your homework. And of course your homework is the practice items. Now as you do your homework, you might say, should I just take any old bit of scrap paper and then write this way and that way and on corners and fold it in half and then do something? And the answer is no, don't do it that way. Get a spiral notebook, some sort of notebook, and then item by item, write it down. It's going to take a little extra time, but you will have a record of what you've done. And then if you have a problem, you put a little star by it, bring it into MyLab, and that's where we help you. The instructor, the tutor that will be there, the student tutors, and this is how you gain mastery. Then when you go to take a test, you go back and you look over your work. And that's actually true for any course. So, okay, it's about 17 minutes long. This is what they are like. You're welcome to do them. It's just another tool in your toolbox.